Alright, welcome back. We just learned in the last video about element-wise and broadcasting operations in NumPy. They are very important in terms of the mathematical operations. In these videos, I will show you some built-in aggregate and statistical functions in NumPy. Let's get started. In NumPy, there are plenty of built-in aggregations and statistical functions for working with ND arrays. That includes the means, the standard deviations, the variance, and also there are some functions, cumulative sum functions, cumulative product functions, and you can also get the mean, max, and also that returns the value. The maximums and minimum value along a given axis. And then also you can check out the arguments or that returns the index of the minimum values along on the x-axis, or you can check the argument max and that returns the index of the maximum values along an axis. For these two functions, they returns the index, and then for these two functions, they returns the values. And you can also use .all functions or .any functions to text where there's all elements or array elements along a given axis. They fit into a certain conditions that evaluate to true. On the other hand, you can text if there's any, not all, elements along a given axis that evaluates to be true in a given conditions. Let's go through the example for each of the functions that I just mentioned. So first of all, we create a 2D array that is kind of like a matrix array, 1, 2, 3, 4, 5, 6, and then we calculate the mean, and we calculate the mean along with different axes. That is another argument. That will provide you a vertical mean, and that will provide you a horizontal mean by defining the x-axis to 0 or x-axis to 1. Now, let me run this out. Okay, let me import SMP. Okay, here we go. We can calculate the mean, and this is just like a global mean. It takes all these figures and then divided by the number of elements inside this 2D array. And for this one, this is a vertical mean, so that you just like a 1 plus 4, and then divided by 2, 2 plus 5, divided by 2, and then it will return you a vector for the mean. And similarly, it will provide, for the horizontal mean, you just need to define the x-axis equals to 1, and then you will get similar results. Similarly, we can work it out for standard deviations. The function is .std, and then you just provide that NumPy and the array. And this is the global. Standard deviations. It takes all these elements. In total, there's 6 elements, and they just try to calculate the standard deviations for all these elements. And of course, you can also define the x-axis by defining the x-axis arguments, and then you can get the vertical or horizontal standard deviations, very similar to the sum, the logic, and variance. Similar to the logics as I mentioned in the above. You can get the global variance by without providing any x-axis argument, and of course you can also calculate the vertical or horizontal variance by providing them the x-axis equals to 0 or x-axis equal to 1 to get these results. Very similar. And then for the sum, it will also just give you a global sums, just plus all these elements, and you will get the total sum, or you can just get the vertical sum, or you can just get the horizontal sum, very similar.
And for the product, again, very similar. You just need to use dot product functions, and you get by multiplying all these elements together, you get this product. And of course, you can also define the x-axis to get the vertical product, and or define the x-axis equals to 1, get your horizontal product. And then for the cumulative sum and cumulative product, you can take a look. And this is the cumulative sum, that is 1, 3, 6, 10, 15, and 21. And let me show you the x so that you can understand what is going on. Because this is a cumulative sum, and we'll just try to add 1 for the first element, 1 plus, because this is the starting point, just there's no other elements is added to this 1, so we just take the 1. And then we can just plus 2. 2 plus 1, we got 3. And then 3 plus these accumulative sum, we got 6. And then 4 plus these accumulative sums, we got 10. So we got the cumulative sum for all these elements. And of course, we can also define theoretical cumulative sums and also horizontal cumulative sum. In order for us to get there, we need to provide the x-axis as well. And for this, say for example, for the vertical one, this is 1 plus 4. We got the first one is 1, and then because the second one is 1 plus 4, we got 5. Again, this is the starting elements, so we got 2, 3, and we just need to plus these 2. 2 plus 5 equal to 7. 3 plus 6, we got 9. Similarly, for the horizontal cumulative sum, this is the starting point 1, 4, 1, and 4. And then we add 2, we got 3, and then we continues to add 3 to this 3, we got 6. Very similar to the above logics. For the cumulative product, we just, instead of calculate the sum, we just calculate the product. Say, for example, for this one, we multiplied all the elements to their previous cumulative products. Say, for example, for ones where this is the starting point, and then the second one is 2 times 1. We got the result. So we got this 2, and then another one is the next one is 3 times 2. We got this 6, and then the other one is this 6 times this 4, we got 24, and the next one is 24 times this 5, we got this 120, and so. And similar, we can define the x-axis to get the vertical cumulative product or horizontal cumulative product. And then for the minimum value and maximum value, they are very similar. And they say, for example, if I want to get the global mean for this x-array, the minimum value is 1. And if I want to get the vertical minimum for each of the column, you can also use provider x-axis equals to 0. So for example, 1, 4, the minimum value is 1, and then 2, 5, the minimum value is 2, and so and so. Of course, we can also define the horizontal minimum by providing the x-axis equals to 1. And the horizontal minimum for these elements is 1, and then for these 3 elements, that is 4. And then we got the horizontal minimum. And similarly, we can just change it to the maximum value to get the global maximum, vertical maximums, or the horizontal maximum. On the other hand, if we would like to not just get the value, or on the other hand, if we would like to get the index that that tell us where these minimum values is. And we can use the argument minimum and to get these value. So for example, the argument minimum for x, that is the first element in this x array, that is the first element. And similarly, we can use the index we can find out the index for the vertical minimum and index for the horizontal minimum, and by providing the x equals to 1 or sx equals to 0. Sorry, sx equals to 0 or sx equals to 1. And lastly, we can just change this to the max to get the index of the global maximum, and or get the index of the vertical maximums or the horizontal maximums along with different axes. And that's it for this video. You don't need to memorize all these functions. You can always refer these functions back to this Jupyter notebook. I will provide you a link that you can download the notebooks whenever you want. In the next video, which is the last videos of this NumPy chapter, I will show you 2 more mathematical operations that are often used in deep learning. They are dot products and matrix multiplications. See you in the next video. Bye-bye.